right? Okay, so we had to
Yes,
start
ma'am.
with rational numbers. Okay, children, before we start with rational numbers, if anybody of you has any doubt, so you can ask me.
Ma'am, I have a doubt, but it's in my reader
You
for
have a doubt
rational
on the
numbers.
okay, yeah. Just 1 second, okay, Duha.
Okay, ma'am.
Duha, you also send me a PDF of linear equations and then of
Yes.
quadrilaterals, right?
Yes, ma'am. Yes, ma'am.
Okay. And you have a doubt from which question? Which chapter?
Ma'am, rational numbers.
You have doubt from rational numbers only. Okay. We'll pick up your doubt. And Mustafa, you there? Put on your camera.
Yes, ma'am.
So Mustafa has sent me algebraic expressions. So children, algebraic expressions is coming for everybody's exam, right?
Yes, ma'am.
Ma'am is coming for my exam.
It's not for Duha's exam. Okay. No problem. Mustafa, put on your camera. Yeah, tell me your doubt, Duha.
Ma'am, it's in square and square roots.
Is it in rational numbers or square and square roots?
No, ma'am, it's in square and square roots. Can I see it at the end of the class? I can't find it right now. That's
Okay,
why.
no problem. No problem. Fine, we can have a discussion in the another class. So now let's discuss with rational numbers, extra questions we had to discuss today. Mustafa, put on your camera quickly. So others, Kumar and Mustafa, if you children also have any doubts, you all can ask me.
No,
Uh,
ma'am.
Ma'am, ma'am, scanning factorization.
Okay, what is the question? Mustafa, tell me your question.
Ma'am, I don't have a question. I was scanning the PDF. I told you that.
Okay, you're scanning the PDF. Okay, fine. No problem. Now, Mustafa, you can send it to me after the class. We are anyways discussing rational numbers. Okay. Yeah, so when you all see my screen.
Yes, ma'am.
Okay. So let's start discussing these questions. First of all, let's quickly revise what are all the properties that we studied in rational numbers. So first of all, what is a rational number? Any number that is written in the form of P by Q. Mustafa, please put on your camera, child. Kumar, you have joined from two devices.
Yes, ma'am.
Have you joined from two devices?
Ma'am, I left that device.
Okay, no problem. It's still showing. Okay, children. So what are rational numbers? Any number that is written in the form of P by Q, where Q is not equal to 0, are called rational numbers, right? For example, I have 1 by 2, minus 7 by 3, 4 by 3, etc. Okay, now one thing is, children, what do you know what is the difference between rational numbers and fractions?
Ma'am, can I tell?
Yes.
Ma'am, fraction, ma'am, the denominator can be 0 or it can be any other number, but in rational, ma'am, where ma'am, its q is not equal to 0, ma'am.
Okay, any other child wants to give me an explanation? Difference between fractions and rational numbers. Yeah. Children, see, even in fractions, the denominator cannot be 0 because any number divided by 0 is undefined value. Like I have 5 divided by 0, this is undefined. This can't be defined because you cannot divide 5 into 0 parts, right? But if you have 0 divided by 5, then that is 0. Okay, remember this point. 0 divided by any number is 0. Any number divided by 0 is undefined. So that is not a difference. That is just a point, children, that you all need to know. The difference in fractions and rational numbers are fractions are basically only positive. Okay, they are only positive. For example, I have 7 by 3, I have 5 by 7, I have 6 by 10, etc. Only positive numbers will be fractions, but rational numbers can be negative also. Right? Now, rational numbers we discussed can be minus 7 by 3 can be a rational number also. If I include minus also, then they are rational numbers. Minus as well as plus fractions are rational numbers, and only positive numerator and denominator if I have, so they are fractions. So can I say positive rational numbers are called fractions? Can I say that?
Yes.
Yeah, so this difference you all must know. Then we have is properties we studied for commutative and associative and distributive properties. So all of these you should know. Then these points are now what is the meaning of additive inverse? Additive inverse means if you have like plus 5 and I say what is the additive inverse of plus 5? So additive inverse is you reverse the sign. What is the sign on 5? What is the sign on 5? So what is the additive inverse of plus 5? Minus 5. What is the additive inverse of minus 3? Plus 3. What is the additive inverse of 7? Minus 7. Okay, what is the additive inverse of minus 10? Plus 10. If you will have a negative number, the additive inverse is a positive number. If you have a positive number, the additive inverse is a negative number, right? Got it? Okay,
Yes,
next is what is the multiplicative inverse? Multiplicative inverse basically means reciprocal. Okay, one second. Before multiplicative inverse, if I add the additive inverses, what number should I get?
0.
0. Like I have plus 5 and minus 5. So when I will add plus 5 and minus 5, I will get 0. So whenever you have additive inverse of any number and you add that to the number only, you get 0 as your answer, right? So adding the additive inverse to the question gives you 0. Then multiplicative inverse means reciprocal of any number. For example, I have 5 only. So the additive inverse of 5 was you were reversing the sign, but now you will reciprocal. For multiplicative inverse, you reciprocal. So now it becomes 1 by 5. If I have 1 by 7, so the multiplicative inverse is 7 by 1. And what is the additive inverse of 1 by 7?
Minus 1 by 7.
Minus. Children, just give me a minute. Yeah, got it. Everybody understood additive and multiplicative inverse. And now one thing is, whenever you are multiplying the multiplicative inverse with itself, like I have 5 and 1 by 5, and then you multiply it. 5 into 1 by 5, this will give you 1 as your answer. 1 by 7 into 7 by 1, this gives you 1 as your answer. Right? Understood this thing? So you will all remember additive inverse means you are writing the opposite sign. Multiplicative inverse means you are reciprocating the number. Adding the two additive inverse will give you 0. Multiplying the multiplicative inverse gives you 1. Right? So next is distributive property of rational numbers. Distributive property basically means you have any number, let's suppose you have 5, and then you have a bracket, and inside the bracket you have an operation, either a like add, either you are adding two numbers or you are subtracting two numbers. So for example, you have 7 plus 3. So how will you open it? Using the distributive law, if they tell you solve it. So what you will do, you will first multiply 5 with 7. Then you will put whatever sign is in between. Then you will multiply 5 with 3. So what do you get? 5 into 7, 35. Plus 5 into 3 is 15. So 35 plus 15, 50 will get. Okay. Similarly, if you have like A into B minus C, what you will do? First, you multiply the outer number with the first number, then minus sign in the outer number with the second number, right? Got this, everyone?
Yes.
Okay. Now, which of the following is not true? Okay. So let's analyze. The first question is 2 by 3 plus 5 by 4 is equals to 5 by 4 plus 2 by 3. Is it true or not? Is it correct?
Yes.
Yes, ma'am.
By which property is it correct? Mustafa, you are not answering.
Commutative property.
Put on your mic and speak. Yeah, using the commutative law. So this one is correct. And which law are we using? Commutative. Second question, 2 by 3 minus 5 by 4 is equals to 5 by 4 minus 2 by 3. Is it correct?
No, ma'am.
No. Why is it not correct? Because commutative
No, ma'am.
property is true for addition. It is true for multiplication. It is true for division. But it is not true for, it is not true for division also. It's not true for division also, but this point is correct. Why? Because we have to write multiplication sign. So that is why this is also correct, this is also correct. But point B is incorrect. Okay, so that is why correct answer is B. Understood this first question?
Yes, ma'am.
Okay, next is multiplicative inverse of 0 by 1 is. Tell me. What is the meaning of multiplicative inverse?
Ma'am,
Reciprocal.
So what is the reciprocal of 0 by 1?
0.
Not defined.
No, you tell me the reciprocal first. I know it's undefined, but it's 1 by 0, and 1 by 0 is a non-defined value. So that is why the option is D. Got it?
Okay.
Next is the rational numbers lying between minus 3 by 4 and 1 by 2 are. We had this type of question in NCERT, right?
Yes, ma'am.
Just 1 minute, children. There's a Azan going on. Okay, just a minute. You can try this by the time. Or wait, you can try easier one. Okay, fine. So let's start. This one I told you, the product of a non-zero rational number and its reciprocal is. So non-zero rational number, can you give me any example?
2.
2. And what is the reciprocal of 2?
1 by 2.
1 by 2.
And what is the product of 2 into 1 by 2? 1. So answer is 1. Okay. Let's come to this question again. We
Ma'am, I have
have
a doubt.
yes, what doubt?
I'm in like some other class or at the end of the class, can we do algebraic identities?
Okay, fine, we can do algebraic identities. Mustafa, tell me one thing. Can you take one more class today?
No, ma'am.
Okay, you can't. Okay, fine, no problem. Because I was thinking now algebraic identities is coming only for you. So I wanted to take a separate class for you.
Maybe tomorrow, like I can do extra one.
Okay, I'll just see to it. Whenever the schedule fits in, we'll schedule one extra for you. Okay, let's for now let's do this only. The three rational numbers lying between minus 3 by 4 and 1 by 2 are. So what we will do for this type of question is, children, first of all, you will like make the denominators equal. Okay, so what can I do? This is 3 by 4, this is 1 by 2. Can I multiply this with 1 by 2 into 2 by 2? This will give me 2 by 4. Right, children?
Yes,
And
ma'am.
now I have the number minus 3 by 4 and 2 by 4. So between minus 3 and 2, can you tell me what are the numbers? I have many numbers, minus 3 and 2. I have minus 2, I have minus 1, I have 0, and then I have 1. So just put the denominator 4, 4. Everywhere you put a 4. So these can be my answer. Just look for the options. Minus 1 by 2, 3 by 0, 3 by 4. No, incorrect. Minus 1 by 4, 1 by 4, and 3 by 4. No, 3 by 4 is not there. These two numbers are there. So incorrect. Then you have minus 1 by 4. Okay, we have it. Then 1 by 4, that also we have, and 0. C option is correct. Right? So how will you do this type of question? When two rational numbers are given to you and they are telling you find rational numbers lying between those two. So you will make the denominators equal and then you will do it. Okay.
Okay, ma'am.
Ma'am, if it's possible, we can also multiply the denominators by 100, right? Or 110 or 1000.
See, we can do that, but Mustafa, I am talking about the questions where denominators are not equal. Here, if you multiply,
Okay.
okay, if you multiply, you will get minus 30 by 40 and 10 by 20. But still, can you now the denominators are still not equal, so you cannot predict what numbers you want to find. Okay, the question that you are saying, I'll give you one example. Look carefully. If I have like this, let's suppose I have 1 by 7 and 2 by 7, and I tell you find rational numbers between these two. Now you say, ma'am, denominators are also equal. How will I find? So children, multiply with 10 and 10. So 10 by 70, 20 by 70, right? Between 10 by 70 and 20 by 70, can you find? I have 11 by 70, 12 by 70, 13 by 70, and 14 by 70, and so on. Till 19 by 70, I'll have many rational numbers. Right? So this type of questions can also come.
Ma'am, I didn't understood.
Okay, Kumar. Did you understand the question that I taught you? Example 3, you understood?
Yes, ma'am.
This part you didn't understand, 1 by 7 and 2 by 7.
Yes, ma'am.
Okay, what happens is, what was my concept? My concept is like, I want the denominators to be equal. Then only I can find the numbers between those two rational numbers.
Yes, ma'am.
You understood this part? Now, in minus 3 by 4 and 1 by 2, the denominators were not equal. So I had to make them equal first. Isn't it? But now,
Yes, ma'am.
1 by 7 and 2 by 7, I already have the denominators that are equal. 7 and 7 is equal. So can you find numbers between 1 and 2? Is there a number between 1 and 2? No. Right?
No.
So what we will do is, we will write 0, 0, 0, 0. Now it becomes 10 by 70 and 20 by 70. You can do this. This is allowed. Okay. And now can you tell me numbers between 10 and 20? Yes, you have a lot of numbers. You have 11, 12, 13, 14, 15, 16, 17, up till 19. You have.
Yes, ma'am.
Right? So you can write all those numbers. Now you understood?
Okay. Yes, ma'am.
Okay, so the next is, if x is equals to 1 by 3 and y is equals to 6 by 7, then xy minus y by x is equals to how much? Okay, a very good question. Everybody will look very carefully. These are the values that are given to you. And this is the value that you need to find. So what we will do is xy. So can I find the value of x into y? Xy means x into y. So x into y is how much? 1 by 3. Look very carefully, everyone. And y is 6 by 7. Okay. And how much is it? 3 into 1, 3 into 2. So my answer is 2 by 7. This is first part. This part I have solved. Now, can I also solve this part, y by x? So y is how much? 6 by 7. And now by x means divided. See, y by x means y divided by x. So 6 by 7 divided with 1 by 3. And how do we solve this? 6 by 7 into 3 by 1. Right? And now you get 6 into 3 is 18. 7 into 1 is 7. So now what I had to do? I had to do xy minus y by x. So I will do 2 by 7 minus 18 by 7. So what do I get? Minus 16 by 7 I get. Clear?
Yes, ma'am.
Okay, children, don't note it down. Just understand. And if you are having problem in understanding, then you can ask me. I'll send you the solutions. All of this annotated thing, I'll send you. Don't worry. So don't note because understand me. You all understood this fifth one?
Yes, ma'am.
Yes, ma'am.
Next is every rational number has a reciprocal. Tell me, does every rational number have a reciprocal?
No, ma'am.
Why no?
Ma'am, because 0.
Very good. 0 is a rational number. Okay, why is 0 a rational number?
Ma'am, because zeros, because the reciprocal of 0 is 1 by 0 and it's undefined.
No, that's okay. That's the answer to the question. But I'm asking you, why is 0 a rational number? Rational numbers are written in the form of p by q, isn't it? But 0 is not in
Yes,
form of
ma'am.
p by q. Then why is it a rational number?
Ma'am, it's because a rational number it can be written in the form of p by q, where q is not equal to 0. But 0
Yeah,
is 0 can be written like 0 out of 10 or 0 out of 9. So 0 is p, not q.
very
That's why
good.
it can be a rational
Exactly.
number.
So 0 is a rational number. Why? Because 0 is a numerator over here. That's the p value is 0. Okay. But the reciprocal of 0 is 0, 1 by 0, and this is a non-defined value. So that means 0 doesn't have a reciprocal. That is why every rational number has a reciprocal. That's why the answer is 4. Now minus 4 by 5 is larger than minus 5 by 4. Now how will we do this? Look, for comparing any numbers where the denominator is not same, here the denominator is not same, you will cross multiply. So minus 4 by 5 into minus 5 by 4. This is cross multiply. This is not multiplying 4 by 5 and 5. So cross multiply, what you will do? Minus 4 into 4 is equal to minus 5 into 5. Not is equals to, you put this comparison box. And now you have minus 4 into 4 is minus 16. Minus 5 into 5 is minus 25. So which is larger?
Minus 16.
Minus 16 is larger. That means we have this number is larger, this is larger, this. That means minus 4 by 5 is larger. Yes, that's true. Okay. Okay, now children, tell me one thing. If I had this number with me, minus 4 by 5 and minus 3 by 5. So can you compare it directly without cross multiplying?
Yes, ma'am.
Yes, ma'am.
What will be my answer? Which is larger?
Ma'am,
Ma'am, minus 3 by 5.
Yeah, so whenever you
minus
have
3 by 5.
same denominator, you will not cross multiply. You have different denominators, you cross multiply and check.
And we can also compare it by LCM, right?
By LCM, yeah, I know that, but that is a longer way of doing it. Because first you have to make the denominators equal, then you have to compare. Right? So you have to first find the LCM, then multiply, then compare. Here you are directly multiplying and comparing. So cross multiplication is easier. Next is finding 4 by 7 into 14 by 3 divided by 2 by 3. So this type of simplification questions can come now. How do we solve this? See, 4 by 7 into 14 by 3 remains as it is. Now children, you have this division sign between. First of all, always remember, I will not solve this part first. Why? Because division, first of all, you solve division sign, then you solve multiplication sign, then you will solve addition, and then you will solve subtraction. Okay. So first, in any equation, if you have division, multiplication, addition, and subtraction, all of the signs you have. Okay, before that also, one more thing. But let's suppose you have a bracket, then what you will do? Like this question, I have to first solve division, right? Why? Because division is solved before multiplication. But if you will have something inside the bracket, let's suppose you have 2 by 3 divided by 1 by 4 plus 7 by 9, and this is in bracket. So you would say, ma'am, division is solved before addition, right? So you would be solving this part first, but no, that will be wrong. Because before division also you will solve bracket. What is inside the bracket, you solve it first. Understood? So whenever you will have simplification problems, if you have a bracket, you will solve inside the bracket first, then division, then multiplication, then addition, and then subtraction. Do you see a bracket in this question, in the eighth question?
No, ma'am.
No, we don't have a bracket. So what will we solve first? What will we solve first? Division.
Ma'am, division.
What do we have? I have 4 by 7 into 14 by 3. So division I am solving. So it changes to multiplication and it reciprocals. Now you can cancel 2 into 1, 2 into 7, 3 and 3 cancel 1 times. So now you have 4 by 7 into 7 into 1 is 7, 1 into 1 is 1. So 7 by 1, 7 into 1, 7 into 1, and you have only 4 by 1 left. That's only 4. Right?
Yes, ma'am.
Everyone is understanding, I hope.
Yes, ma'am.
Yes, ma'am.
Okay, next is using appropriate properties. Find the value of 2 by 3 into 5 minus 5 by 7 plus 7 by 3 plus 2 by 3 into minus 2 by 7. Now, children, if you remember, this type of question was there in NCRT also, where we had a long sort of equation with us, and there was something common, if you remember. Can you find something common over here also?
Ma'am, denominator is 3
Ma'am.
and 7.
No, do you see, if you have rational numbers, do you see any rational number that's common?
Ma'am, 2 by 3 is common.
So I have a 2 by 3 here as well as over here. So children, now if you look at the pattern carefully, don't look at numbers. This is the first number, second number. They are being multiplied. So this is under one bracket. Okay. I can assume that this is under one bracket. Why? Because they both are being multiplied. Then you have 2 by 3 and minus 2 by 7. And it is also being multiplied. That means it is under one bracket. Right? And then you have plus 7 by 3. That means you have 2 by 3 into minus 5 by 7. Then you are adding 7 by 3 to it. Then you are multiplying 2 by 3 into minus 2 by 7. Then you are adding everything. So you have three terms over here. First term, second term, and third term. And all the terms are being added. Right? Children, you will remember one thing. When any two numbers are multiplied, you consider that to be one term only. Okay, like I have 7 into 3. See, I'll explain you like this. 7 into 3 plus 5 plus 7 into 4. Okay, let's suppose this is the question. So these both numbers are being multiplied. So I will consider them one only. This is first term of my equation. Then this is not multiplied with anything. So this is second term of my equation. 7 and 4 are again being multiplied. So this is third term of my equation, right? Now how will I solve it? Look. So I can take something common over here. And what can I take common is 2 by 3. 2 by 3 I can take common because 2 by 3 is here also, 2 by 3 is here also. So what will I do is, first of all, I will write 2 by 3 into minus 5 by 7 under one bracket, then addition sign, 2 by 3 into minus 2 by 7 into another bracket, then plus 7 by 3. I have just separated 7 by 3. I have moved it, and I can do it by using the law of associativity that is allowed. Associative law is valid for addition, right? These all three terms were added. So I have just changed their positions.
I have a question.
Yes.
For 2 by 3, can't you just solve in one bracket 2 by 3 into 2 by 3?
2 by 3, like you want to solve this part, then this part, and like that?
No, like you break 2 by 3 into one bracket, so it's 2 by 3 into 2 by 3.
No, you can't do that. How can you see? 2 by 3 is not being multiplied with 2 by 3. This 2 by 3 is being multiplied with minus 5 by 7. And then this 2 by 3 is being multiplied with minus 2 by 7. And the whole things are being added together. So how can you multiply them? Understood or not?
Ma'am, I have a question.
Yes.
Ma'am, can we also use the distributive property here?
We are using the distributive property only. It's written using appropriate property. So first I came to this using associative law. Now I will use the distributive property. Distributive property was the one only. So I'll first take common 2 by 3. Now in the bracket, from this bracket I have minus 5 by 7. From this bracket I have minus 2 by 7. And there was a plus sign in between. So not to worry anything about the sign. And then plus 7 by 3 remains as it is. Now I have 2 by 3 minus 5 by 7 and minus 2 by 7 is minus 7 by 7 plus 7 by 3. Right? So this becomes minus 2 by 3. 2 by 3, this becomes 1. Minus 1, 2 by 3 into minus 1 is minus 2 by 3. And plus 7 by 3 is how much? 5 by 3. Got it? What is our answer? 5 by 3. Everyone now try to do this question on your own because this is a very important question. It's there in NCERT also. 2 or 3 questions are like there. Solve this and tell me if you understand or not.
Ma'am, I have a question.
Yes.
Ma'am, if in the exam it comes that, for example, 2 by 3 into minus 5 by 7.
1 minute. I'm sorry to interrupt. Please just. Yes. Yes, Duma.
Ma'am, yeah, ma'am. If in the exam it comes like 2 by 3 into minus 5 by 7 plus plus 7 by 3, sorry, not plus 7 by 3, plus 2 by 3 into minus 5 by 7.
Okay, that basically means the same thing. That means you are multiplying two same numbers, right? 2 by 3 into my. So there you don't really have to use any property. Like this only you were saying, right?
Yes, ma'am.
If you want to use, if the question says use a property, take any one number common. Either take 2 by 3 common or minus 5 by 7 common and write what is left inside the bracket. So this becomes 2 by 3 minus 10 by 7. You will have minus 20 by 21. Okay.
Okay, ma'am.
Yeah, so children, any doubt in this question?
No, ma'am.
All clear, right?
Yes, ma'am.
Now next is, the question says, let O, P and Z, 1 minute. Children, let's do one thing. Now we can discuss algebraic expressions because there are many questions of this lesson. Now we can continue in the next class for rational numbers. Let's do algebraic expressions, okay? Dua, you can listen because anyhow your portion has been completed, right? Or is there a chapter that's left for you?
Ma'am, comparing quantities and practical geometry is left.
And is that coming for Kumar? That was coming only for you, right? I discussed this in last class.
Yes, ma'am.
So, Duha, for you, can I take one more class?
Ma'am, today I can't have a class.
Today you
Ma'am,
can't.
but tomorrow is fine.
Okay, fine, I'll see to that. So, for now, let's discuss algebraic expressions. Duha, I'll complete that lesson with you also. Don't worry. But you can also learn this, okay? Now we have. Yes, Mustafa, you wanted to ask a specific question, or shall I just start with the lesson only?
No, ma'am, I only have doubt in the identities.
You sent me 2 PDFs.
Yeah, one
So
is for factorization and one is algebraic expressions.
you want to have so identities are there in factorization, right?
Yeah, algebraic also.
So identities. Do you know the basics like? Okay, let's do one thing. Let's start with the entire thing. Okay, so children, look very carefully. In algebraic expressions, first of all, children, you should know what is the meaning of basic things. Like you should know what is the meaning of terms, what is the meaning of coefficient, what is the meaning of like and unlike terms. So what is the meaning of term? Basically, when I have 7x square plus 3x plus 4. So over here, I have 3 terms in this expression. This is the first term, this is the second term, this is the third term. Okay, so the individual numbers are represented as terms in an algebraic expression. What is the meaning of coefficient? Coefficient basically means over here the coefficient is the number that is attached with the variable. Okay, like over here I have x square. So what is the coefficient of x square? 7, because 7 is attached with x square. What is the coefficient of x? 3, because 3 is attached with x. Now what is the coefficient of 4? Doesn't have a coefficient. Why? Because 4 itself is a constant term, right? So coefficient are basically the numbers that are attached with variables, and variables are letters. Like here you have x square and x. Now children, in terms I have like terms and unlike terms. If you remember, when we did addition and subtraction of algebraic expression, we could only add like terms together. For example, if I have 7x square plus 3x plus 4, and I have another expression 5x plus 3 plus 10x square. So over here, 10x
Ma'am, I
square,
can't see your annotations. Can't see.
you all can't see my annotations. One minute.
Yes, ma'am, I can't see it either.
You all see it now. 1 minute. See it now?
Yes, ma'am.
Yes,
Okay. Okay. So, like 10x square is a like term with 7x square. Why? Because the variable is same. So, like terms are the ones that have the same variable with them. Like 10x square and 7x square are like terms. 3 and 4 are like terms. 5x and 3x are like terms. Like that. And unlike terms are like 5x with all the other things are unlike. If 5x and 7x square are unlike, 5x and 4 is unlike. Right? So, basic points are clear with everyone.
Yes, ma'am.
Yes, ma'am.
Okay, now what are polynomials, children? The definition of polynomial, if you look very carefully, it's basically whenever I have an algebraic expression where the variable does not have under root with it or a negative power with it. It should not have these two things. Okay? It should not have a negative power. It should not have under root. It should not be in division. And division and negative power means the same thing, but still, for your reference, you should know it should not be in this format. For example, I have 2 under root x plus 3 x square. Is this an algebraic expression? Yes. Is this a polynomial? No, this is not a polynomial. Because for it to be a polynomial, all the variables should have a positive power. Here x has under root power. So it is not a positive as well as an integer one. So under root power basically means power of 1 by 2. So that is why this is not a polynomial. Like if I have 3 by x plus 7x square, is this a polynomial? No. But is this an algebraic expression? Yes. These all are algebraic expressions, but they are not polynomials. Right, children?
Yes.
Clear with one? Now next we have is what are the various kinds of polynomials you can have. So we can have a monomial. Monomial is basically a polynomial with one term. What is a binomial? Binomial has two terms. We studied this in multiplication of algebraic expressions, if you remember. Then trinomial. Basically, trinomial and see, from three terms onwards, it is called a polynomial. Okay. But trinomial also you can refer if they ask you, that's three terms. Now, next is degree of a polynomial. So degree is basically, how do you define a degree? Degree is the highest power of a variable. For example, I have a polynomial like 7x squared plus 3x plus 10. So over here, what are the variables? X square and x. These are the variables. Now, what is the power of this x? The power of this x is 2. And what is the power of this x? 1. So which is greater? 2 is greater or 1 is greater? 2. So what is the degree of this polynomial? 2 is the degree of this polynomial. Right? If I have 10x to the power 10 plus 9x to the power 11 plus 7. So what is the degree of this polynomial?
11.
Degree is?
Ma'am, x to the power 10.
11.
Children, I can't hear you.
Ma'am, 11.
11. Yeah. Degree is 11. Right? So degree is clear. So, Mustafa, just look at the first exercise and tell me if you have any doubts from there. Because there you have to classify polynomials. Or wait, let's do one thing. I will share only. Yeah, you all see my screen? Do you all see my screen?
Yes.
Yes, ma'am.
Look very carefully. Over here, which of the following expressions are polynomial? So first one, yes, it is a polynomial. Second one, is it a polynomial?
No, ma'am.
No, this is not a polynomial. Why? Because it has a power of 2 by 3. So the power can be only a positive integer. Is this a polynomial? Yes. Is this a polynomial? Yes. Even constant numbers are polynomials. This is called a constant polynomial. But this is a polynomial, okay?
Ma'am, how is y to the power 3 a polynomial?
Y cube is a polynomial. Why is it not a polynomial? It has a power, it has a coefficient as 1 and power is 3. So it is a polynomial. It's not necessary that you're going to have more than, it's a monomial. Polynomial with one term was called a monomial, right?
Okay, ma'am.
Is this a polynomial? Is the fifth one a polynomial?
No, ma'am.
No, ma'am.
No. Why? Because it has a negative power over here. This one, no. Negative power. This one, no. Fractional power. This one, yes. No negative power, no fractional power. This one, no. X is in division, so no. Then this one, yes. It is a polynomial. It has many terms, but all of the terms has positive integer value parts. This one, no, because of 1 by 7. This one, no, because you're 2 by 3 and 2 by 3. This one, again, no, because cube root is there. This one, no, because square root is there. This one, again, no, square root as well as division is there. Right?
Yes, ma'am.
Yes.
Take a screenshot, everyone. Quickly take a screenshot. Done? Okay.
Yes.
Next is state which of the expressions in question 1 are monomials, binomials, trinomials, polynomials, and non-polynomials. So I'll tell you what are monomials and binomials. So over here, monomials I see is this C. C is a monomial. Only C is a monomial. So YQ. Binomial, how many are binomial? This is a trinomial. Then this is a polynomial. It has 4 terms. Then this one has 3 terms. So this is a trinomial. Then, so we don't have binomials. Binomials, there are no binomials. Trinomials, there are 3 trinomials. Second one, first one, H part and J part. Okay. Next is state the degree of each of the following. Degree of this polynomial is 1. Why? Because the power of x is 1. Okay. What is the degree of this one? B part?
Mom, 2.
2.
2.
Third one?
Mom, 1.
See now what happens. Degrees of polynomials. This is actually a polynomial in 2 variables. Okay. So here you can write, okay, degree is 1 only because both of them have just 1 degree. 1 power. So here also 1 degree. Here the degree is, see, in terms of x the degree is 3 and in terms of y the degree is 2. Right?
Yes, ma'am.
Yes.
In
Mom.
terms of x the degree is 3. In terms of y it's 2. Here in terms of x the degree is 4. Here in terms of x the degree is 6. In terms of y the degree is 4. In terms of x the degree is 4. In terms of a degree is 4. In terms of b the degree is 1 only. Degree is 3. Degree is 6. Okay. Next is given below are polynomials in one variable. Arrange them according to the descending order of the degrees. In the descending order, that means highest degree first. So I will write, okay, all of them you have to arrange. So this has a degree 4, this has a degree 5, this has a degree 3, this has a degree 3, this has a degree 3. So number 1, you will have B option, then A option, then C, D, and E will be in one category, right?
Yes.
Then addition and subtraction of polynomials. This part we have already done, so we will not do this part now. We've already done addition, subtraction, and multiplication in the class. Do you have any doubts from this part? Second exercise, you have a doubt, Mustafa?
No, ma'am.
All clear, right?
Yeah.
This area, can you find length, breadth, and breadth of a rectangle? Length is 2a plus 3b plus 4b. This is the length. This is the breadth. So what is the formula for area of a rectangle? Area of a rectangle is length into breadth. So it is 2a into plus 3ab plus b multiplied with a plus 3b. You multiply it and get your answer. Okay. Division of polynomials also we have done. The solving part. Now children, what happens whenever you have, look here, p to the power 100 divided by p to the power 2. So this question, children, tell me one thing. Is it a question of algebraic expression or do you see it as a question of exponents and powers? Can I do it by exponents and powers? Right?
Yes.
I
Yes,
have
ma'am.
2 numbers that are being divided. So you subtract the powers. So power is p to the power 98, 100 minus 2. M to the power 3, 6 minus 3. X to the power 20 by minus 4 is 16. Y to the power 5 minus 3 is 2. Here also, first you will divide. This becomes 4. So 4 x to the power 7, y to the power 2. Like this, children, you can do all this. Okay, next you have is the simplification questions. What if you have a single denominator with two numerators? So you will first of all separate this thing. How can I separate it? Can I write this as 8x by 8 plus 8y by 8? 8 and 8
Yes,
cancel.
ma'am.
8 and 8 cancel. So I have it as x plus y. So next will be 100x by minus 4. Then minus 60y by minus 4. And this one also then you can simplify. Simplification. Yes. Any doubts in simplification questions? Any doubts in simplification questions, Mustafa? 7D exercise.
Ma'am, we can't do it directly. You have to separate it, right?
How will you do directly?
I was just asking.
No, you can't. You can't. You will have to separate it and then show. Okay. Now, children, these questions are important. I'll give you these questions as your assignment ones. Okay. These are important ones. Next you have is, okay, you have the long division method also. Is it there in your syllabus? Is it coming?
Yes, ma'am.
Okay, look here. I'll teach you this. Let's take one example. I'll teach you here. Everyone will look very carefully. Let me refer to the question. Okay, children, the question says 2a plus 1 you have to divide by 6a square minus 7a minus 5. So 6a square minus 7a minus 5 you are dividing with 2a plus 1. So how will you do this now, children? Everyone will look very carefully. It's important. First of all, what is the first number that you see over here? 2a, right? And what is the first number that you see over here? 6a square. So how many times does 6 comes in the table of 2?
T.
3 times.
3.
So I have 3 over here. And a multiplied with what will give you a square? A only. A into a is a square. So you will write 3 over here. This 3a I can get like this also by directly thinking. Or I can also do in rough column. I can take this 6a square divided by 2a. So 2 into 3 is 6 and a square divided by a is a. So like this also I could have got 3a. You can do it directly as well as in rough column you can divide. Okay. So you get 3a. Now what you will do is you will take this 3a and you will multiply it with entire thing. So 2a into 3a is 6a square. 3a into 1 is 3a only. Plus 3. 3a into plus 1 is 3a. Now you have to subtract this. So children, you remember in subtraction, we used to change the signs. This becomes negative. This also becomes negative. 6a square minus 6a square is 0. Minus 7a and minus 3a is minus 10a. Got this? Now you will carry down
Yes.
minus 5. Okay. Now what you have is, again do the same thing. The same thing you will do. You take this number, divide them in rough. Minus 10a divided by 2a. What does it give you? Minus 5. Because a and a cancel, 2 into minus 5 is 10. So you get minus 5. Now you will take this minus 5 and multiply with the entire thing. So 2a into minus 5 is minus 10 only. 1 into minus 5 is minus 5 only. Now we have to subtract. So to subtract, we used to change the signs. This becomes plus, this becomes plus. Minus 10a plus 10a is 0. Minus 5 plus 5 is 0 again. So what is our question? 3 and minus 5 are question and 0 is our remainder. Got this everyone? This is rough column.
Yes, ma'am.
Understood?
Yes, ma'am.
Everybody take a screenshot.
Yes, ma'am.
I'll practice one more question, okay? Come to this one. Let's suppose the question is divide 5y cube plus y minus 3 by y minus 1. So look here again. First of all, you take y minus 1 over here and 5y cube plus y minus 3 you will write over here. Now what you will do is you have, okay children, one more thing that I missed is the number that you are writing inside the bracket. Like this is the number that I have to write inside the bracket. Now the powers of that number should be in ascending order. Okay, like you have power 3 and this is power 1. Power 2 is missing. So in place of power 2, you will write 0. Before only you write 0. And now you write y and now you write 3. Whatever power is missing, you will write 0 for that. Okay? Understood this? Now again, do the same thing.
Okay.
First, you will take this and this. Yes, Duha?
Yes, ma'am. Ma'am,
Okay.
I have a
So
question.
first you will take. Yes, Duha, what is your question?
Ma'am, why can't we use 1 instead of 0?
No, you can't. Okay, tell me one thing. 5 plus 1 it gives you 6. That changes your answer. But 5 plus 0 remains 5 only. We don't have to change the question. So you add 0.
Okay.
Okay. So 5y cube divided by y is how much? 5y square. So you will take 5y square over here. Multiply y with 5y square. You have 5y cube. Minus 5 plus into 5y square is how much? Minus 5y square. Subtract. This becomes 0. This becomes.
I have a question.
Yes. Yes, Mustafa.
Ma'am, we don't need to add the 0. I just put them in order, ascending order.
Okay, tell me one thing. Let's suppose you're not adding in ascending order, you're saying.
No, ma'am, descending order, I'll say.
Descending. Okay, tell me one thing. If we are not adding the 0 over here, then what will happen is our solution will become a little messy if I have like this. Let's suppose I did not add 0. Wait, first I'll solve my part, then I will come to this. Okay, so look here once. So 0 over here, now you have 5y square. Now you carry y. Now what do you have? 5y square divided by y is how much? Minus 5y only. Here you get minus 5y square. Here you get plus 5y. Okay. So plus minus, you get a 0. Here you get minus 4y. Now again, children, you carry down minus 3. You divide minus 4y with y, you get minus 4. So minus 4 into y is minus 4y. Minus 4 into minus 1 is plus 4. This becomes plus, this becomes minus 0. And answer is minus 7 is the remainder. And 5y square minus 5y minus 4 is the question. Now, the thing that Mustafa is saying, what if we are not adding 0? So see, I will have it. I will have my answer. First of all, I will take 5y square. Okay. Now I will have 5y cube. Now 5y square into minus 1 gives you 5 minus 5y square. Where should I write minus 5y square? I cannot write it like over here. Can I write it like this? Below plus y. Tell me.
No, ma'am.
No, I can't write it like. Even if you write it, even if you think I will write it, but I will not solve. So when you are carrying down y, you have to make a line like this. That becomes unneat. The solution becomes messy. So we always want to make our solutions neat and clean for the examiner to understand it and give us marks as soon as possible. So this is the proper correct solution. Okay. Add 0. if any term is missing. Now you don't do this thing that I give you the question y square plus y plus 3 and you say, ma'am, y to the power 3 is missing. No, y to the power 3 is not missing. It's starting from y square only. So after y square, you see what terms are missing. Okay, like that you have. Understood?
Yes, ma'am.
Yes, ma'am.
Okay, children. So for today, we'll just keep it up till here only. I hope you all understood well.
Yes.
Yes, ma'am.
Yes.
Okay, any doubts?
No,
No,
ma'am.
ma'am.
Okay, fine, children. So you all can go for now. We'll continue it in the next class, right? Just complete your assignments and submit them. Bye, children.
Thank you.